Hey everybody, welcome back to Mr. Aparicio's geometry course. Today we're going to go over section 1.3 on the distance and midpoint formulas. In our last section 1.2 we learned about linear measure and how to find the distance between 2 points with the segment addition postulate. We're going to continue the theme of measuring distance, but today we're going to be doing it on the coordinate plane. So let's see how that changes. In our previous lesson, we learned about distance on number lines. On the coordinate plane, number lines are essentially your x-axis and your y-axis. So on those axes, measuring the distance between points is no different than it is in 1.2 because of the horizontal nature and the vertical nature of those lines. We can just count those distances with our fingers. So if I wanted to know the distance between a point that was located at -3, 0, and 2, 0, I could just count that distance. So it's 1, 2, 3, 4, 5. Distance between those is 5 units long. We do the same thing vertically. If I want the distance between +5 and -1, again, I can just count that. 1, 2, 3, 4, 5, 6. Those are 6 units apart. Where it gets tricky on the coordinate plane is when our points are not horizontal or vertical to each other. So if I had a point here at -3, -2, point right there, and a point here at 5, 1, this is now a diagonal distance, so the length of that segment that I've drawn there can't be counted by your finger. We're going to have to use a formula in order to find that, and that formula is the distance formula. So we have lowercase d for distance equals the square root of, in parentheses, x2 minus x1, that value squared, plus y2 minus y1 squared. This formula is provided on the reference sheet for your end of course exam. It does not technically have to be memorized, though it will serve you well to memorize it because we are going to use this formula a lot in geometry. So let's see how we can put that formula to use. We're being asked here to find the distance between points E and F. I have a graph here just to show you that sometimes your points are going to be horizontal or vertical to each other, and you could just count with your finger. Let's see if that happens here. Point E is at -4, +1, which is located right there. Point F is at +3, -1, which is located right here. So these points are not horizontal or vertical to each other, so we cannot just count those with our fingers. We must use the distance formula in order to find out the length of the segment or the distance between these 2 points. All right, I'm going to copy down the distance formula for you here so we can see it on screen. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Something I urge everyone to do when they're using the distance formula is label the points that we're going to use in the formula. So our given points are E and F. Remember that every point has an x coordinate, that's the first value, and a y coordinate, and we're going to label those for both points. So I'm going to pick a point, it doesn't matter which one, and I'm going to label the coordinates x1 and y1 on that point. And I'm going to go ahead and do that for point E, so x1, y1. And then I'm going to do the same thing for the other points, but now I'm going to give it the 2's, so that's going to be x2 and y2. What matters here is that we have the 1's together at the same point and the 2's at the same point, right? I could have flipped these and labeled this x2, y2, and this x1, y1. I would still get the same answer in my formula. What I cannot do is label this x1, y2, right? And this x2, y1. I would get an incorrect answer in my formula. So 1's together, 2's together. Once we have them labeled, we're going to substitute those values into our distance formula and then do the algebra to solve for the distance. So here's what that will look like. So distance equals, I have my square root sign. Very common mistake is people forget to put that square root sign and it results in an incorrect answer in the end. And then I'm plugging values in. So my x2 is +3. My formula says to subtract, so I'm putting a subtraction sign. My x1 is -4, so I'm going to write -4. I know that doesn't look pretty, but I like putting things in with the exact signs that they have and then cleaning things up in the next step of algebra. Then we have y2 minus y1. So my y2 is labeled as -1 minus y1, which is 1. So that's plugging my values into the distance formula. From there, we're following the order of operations. So we have PEMDAS. Please excuse my dear Aunt Sally, P standing for parentheses. So that means I need to do the functions in the parentheses to start this. 3 minus negative 4, it's really 3 plus 4, that's positive 7. Negative 1 minus 1, negative 2. After parentheses, we would do exponents. So now I need to do that 7 squared, which is 49. Negative 2 squared is positive 4. Remember, after you square numbers in the distance formula, you will never have anything negative at this step. You should always have positive values. Then we add those values together to get the square root of 53. Now at this stage of geometry, we are not going to simplify radicals and we are not going to round the decimals from the square root. So we will leave our answer here as the square root of 53. Now, as an example, if I got a resulting answer of the square root of 64, well, that is 8. So I would actually take that square root and leave that answer as 8. In this case, the square root of 53 is a decimal, 7 point something. Again, we're not going to round that decimal. We just have an exact distance here between E and F of the square root of 53 units long. Okay, here's an opportunity for you to test your skills with the distance formula. Please pause the video and see if you can find the distance between E and F in this example. Okay, hopefully you remembered the first thing that we need to do here is label our points. So I'm picking one point to label x1, y1, the other point x2, y2, and then I'm plugging those into my distance formula. So distance equals the square root of, remember our first parentheses is always x2 minus x1. So our x2 here is 8 minus my x1, which is negative 5. So 8 minus negative 5 squared plus y2 minus y1. So I got negative 4 minus 6. So plugging everything in carefully from there, we're following order of operations. First thing I need to do is my parentheses. So I'm doing 8 minus negative 5. You guys have access to calculators in class and at home. Use them. Don't make any silly errors with your subtracting and adding with negatives. 8 minus negative 5 is positive 13. Negative 4 minus 6 is negative 10. After parentheses, we need to do our exponents. So 13 squared is 169. Negative 10 squared is 100. We add those together and we will get the square root of 269, which would result in a decimal and not a whole number. So we would leave this as our exact answer for the length of segment EF, square root of 269. Okay, we have a great example here now of a lot of things that we've learned here in geometry. First, some reading, right? We have to understand what this question's asking. It's asking to determine if segment MA is congruent to segment AT. Recall that congruent means equal in measure. So we're trying to find out if we have two segments in here that are the exact same length. MA being a segment that we cannot count because it's diagonal. So remember, that means we're going to have to use the distance formula to figure out how long the segment MA is. AT, however, though, is horizontal. We can count that. We don't need to use the distance formula in this case. From A to T, I can just count 1, 2, 3, 4, 5, 6 units long. No distance formula required. We know that AT equals 6. So now for MA, we're going to use our distance formula, and if we also get a value of 6, then our answer would obviously be yes. These segments will be congruent to each other. So again, that will require the distance formula in order for us to solve that. So in this case, I'm going to take the points that I need for MA. I'm also going to be organized here as I do this. Look, I'm going to write segment MA, little colon. That way I know everything next to this is to find the distance of that. Very important to stay organized with your work in geometry. There's some examples where you'll have stuff all over your paper, so stay as organized as possible. I'm going to go ahead and write down the locations of those endpoints at negative 4, negative 2, and negative 2, positive 2. And the only reason I'm doing this is so that I can label them. Remember, extremely important. Don't be lazy with your labeling. One point is x1, y1, the other point is x2, y2. Then we're plugging those into our distance formula. So square root of x2, so negative 2, minus x1, x1 is negative 4, plus y2 minus y1. Then we're following an order of operations, all right? So starting off with parentheses, negative 2 minus negative 4, it's really negative 2 plus 4, which is positive 2. 2 minus negative 2 is really 2 plus 2, is positive 4. Remember, use your calculators if you're not confident with adding and subtracting with negatives. Next, doing exponents. 2 squared is 4. 4 squared is 16. We add those together to get the square root of 20, which is 4 point something. It's definitely not 6. So segment AT, we counted at the start of this, was 6 units long. Segment MA is not 6 units long. So these segments are not congruent to each other.